Hello students, I am A.K. Dubedi. Welcome to part 1 of our Atoms and Molecules series. Today we are going to talk about atoms and molecules. Learning objectives are recall and basic postulates of Dalton's atomic theory. Define atoms, molecules, ions, atomic mass, molecular mass. State the law of conservation of mass and the law of constant proportions. Apply the law of chemical combination to solve simple numerical problems. Derive a chemical formula from the given valencies. Analyze experimental data to verify the law of conservation of mass. So, atoms and molecules is very important for class 9. We know that class 9 is a basic of IIT and NEET examination. We know that IIT and NEET examination is based on 4 grades: class 9, class 10, class 11th and class 12th. Class 9 is directly connected with class 11th and class 10th is directly connected with class 12. In this chapter, in atoms and molecules, according to ancient thought about atoms and molecules, according to Indian philosopher Maharshi Kanad, matter is divisible, means matter is easily divided into small fragments. Indivisible particles were named as Pramanu. A smallest indivisible particles is known as atom. Atom is known as atom, and atom is uncuttable, means atom cannot be divided in small fragments. In some cases, atoms may not exist in the free state, but may exist in the combined state in the form of species called molecules or compounds. Molecules or compounds. So, on the basis of a very simple concepts, matter, on the basis of simple concept, we can conclude that matter is made up of small particles which may be atoms or molecules. As different kind of matter contain different types of atoms or molecules which have different properties, therefore different kinds of matter have different properties. In nutshell, different kinds of matter have different properties, and this one is explained on the basis of law of chemical combination. In class 9, law of chemical combination is divided in 2 parts. Number 1 is law of conservation of mass and number 2 is law of constant proportion. So, law of conservation of mass is given by Antonio Lavoisier in 1774. According to him, mass can neither be created nor destroyed in a chemical reaction. I am going to again explain. Mass can neither be created nor destroyed in a chemical reaction, or in other words, in any chemical reaction, the total mass of the reactant is equal to the mass of the product. So, in one line, mass of reactant must be equals to mass of product. For example, calcium carbonate on thermal decomposition gives calcium oxide and carbon dioxide. The molecular formula of calcium carbonate is CaCO3. On heating gives calcium oxide plus carbon dioxide. Chemical formula: calcium carbonate contain calcium atom, one calcium atom, one carbon atom and 3 atoms of oxygen. Mass of calcium is 40 gram, mass of carbon is 12 gram and mass of one atom of oxygen is 16. Total number of oxygen is 3, so 16 into 3. Total mass of reactant becomes 100 gram. On thermal decomposition or on heating, calcium carbonate gives calcium oxide and carbon dioxide. Mass of calcium is 40 gram and mass of oxygen is 16. So, mass of calcium oxide is 56 gram and mass of carbon is 12 and oxygen is 16 and oxygen 2 oxygen atoms. So, 16 into 2. So, 44 gram is the mass of carbon dioxide. So, 56 is the mass of calcium oxide and 44 is the mass of carbon dioxide. So, total mass becomes 100. So, mass of reactant is equals to mass of product. So, on the basis of law of conservation of mass, in-text question is given, intra-in-text question. When 4.2 gram of sodium hydrogen carbonate, that is NaHCO3, sodium hydrogen carbonate is added to a solution of hydrochloric acid, means sodium hydrogen carbonate plus hydrochloric acid weighing 10 gram. It means 4.2 gram of sodium hydrogen carbonate and 10 gram of hydrochloric acid. It is observed that 2.2 gram of carbon dioxide gas is released and into the atmosphere and residue left behind is found to weigh 12 gram. So, on the basis of this observation proves that the law of conservation of mass. So, in this case the mass of reactant and mass of product. So, first of all identify the reactant involved in this chemical reaction is sodium hydrogen carbonate and hydrochloric acid, and product formed with sodium chloride, water and carbon dioxide. But according to question, sodium chloride and water is a residue, CO2 gas is evolved, CO2 gas is released and sodium chloride plus water is left as a residue. So, first of all identify the mass of reactant. So, mass of reactant is given 4.2 gram of sodium hydrogen carbonate and 10 gram of hydrochloric acid. So, the total mass of reactant is 14.2 gram and the mass of product is divided in two parts, not in the form of sodium chloride, water and carbon dioxide. Mass of product is divided in two parts, mass of carbon dioxide and mass of the residue. Residue means the amount left after the removal of carbon dioxide. Left amount is known as residue. So, mass of CO2 is given according to the question 2.2 gram and mass of residue is also given 12 gram. So, the total mass is 14.2 gram. Total mass of the product is 14.2 gram. So, 12 gram plus 2.2 gram is equals to 14.2 gram. So, mass of reactant and mass of product are same. So, there is no loss or gain of mass during the reaction. No loss or gain of mass during the reaction. During the reaction, this is the product. During the reaction, hence the given observation prove that law of conservation of mass. So, again I am going to explain. Law of conservation of mass means mass of reactant must be equals to mass of product. Then second law of combination is law of constant proportion composition or law of definite proportion, given by G.L. Prosto in 1799. According to him, a chemical compound always made up of the same elements combined together in the same fixed proportion by mass. A chemical compound always made up of the same elements combined together in the same fixed proportion by mass. So, on the basis of simple example, we know water, the source of water, any source of water like tap water, river water, rain water, lake water, ocean water, or sometime water come from the AC. So, in case of water, two atom of hydrogen and one atom of oxygen. This is the molecular formula of water. Mass of hydrogen is 1. So, 2 atom of hydrogen means 1 into 2, 2 gram hydrogen combines with 16 gram of oxygen. So, simplest ratio is 1:8. So, water formed from any source, the composition is fixed. So, any compound, another example, suppose carbon dioxide is formed by the burning of carbon with oxygen, by heating limestone, by heating sodium carbonate with hydrochloric acid, gives carbon dioxide. So, in carbon dioxide 12 gram of carbon combines with 32 gram of oxygen and the ratio is 3:8. Again, so any compound formed from any source, the rate of combining ratio by mass is always fixed, and mathematically we are able to calculate the percentage of an element in a compound, just like mathematics, given mass upon total mass into 100. How to calculate percentage? Given mass upon total mass. So, mass of that element upon mass of the compound into 100. So, again at the rate of in-text question, very simple question, hydrogen and oxygen combined in the ratio 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? So, very simple question. In water, the ratio is 1:8. It means 1 gram hydrogen combines with 8 gram of oxygen. So, according to question, 3 gram hydrogen combines with how many gram of oxygen? So, 3 is 2 into 8, 3 into 8 equals to 24 gram. On the basis of simple law of constant composition, first of all identify the ratio in the given compound. Like water, 1 gram of water combines with 8 gram of hydrogen. This ratio is fixed. So, on the basis of the question is how many gram of hydrogen completely combines with oxygen. So, 1 gram combines with 8 gram. So, 3 gram hydrogen combines with 24 gram. Then assessment, please give the answers of some question, multiple choice questions. So, according to Maharshi Kanad, ancient thought, what were the smallest indivisible particles called? Atoms, Pramanu, molecules or compound. It is your duty to identify the answer. In next class, I am going to explain the answer of these questions. What is the law of conservation of mass? Creating new matter, destroying existing matter. Mass cannot be created or destroyed in a chemical reaction. Changing mass of the element. Third question is, what is the law of definite proportion concerned with changing chemical reaction? Chemical compound always made of same elements in a fixed proportion. Creating new element, measuring atomic weight, and how do hydrogen and oxygen combine to form water? A random proportion in a fixed ratio by 1:8 by mass, 2:1 ratio, verifying proportions. What defines a molecule according to the document? A single atom, a random combination of element, atoms existing in combined state, and indivisible particles. So, answers are also given in the same question. So, please identify the answer. Thank you for watching. In next class, I am going to explain Dalton's atomic theory.